Hey, I just want to give a quick rundown of this tool head, this Volcano tool head I'm working on for a 3D printer. First of all, the grabbing mechanism for it is based on a magnet. So right here, I just have a 1-inch steel washer that will eventually be replaced with a 1-inch diameter samarium cobalt magnet. I'm using samarium cobalt instead of neodymium because samarium cobalt is it can go up to, well, much higher temperature than neodymium before it loses its magnetism. Neodymium can only go to like 80 Celsius, I believe. Well, this is, I forget if it's like 100 or 120 Celsius, but it's a fair bit higher. It might even be more than that, I forget. So first of all, this is a Volcano tool head. I like the Volcano style hot ends because they're fairly simple and they work well for me. I don't see any quality drop going from a V6, like a regular V6 to a Volcano. I never print with any nozzle smaller than 0.4 millimeters, so this makes sense to me. Yeah. I also have a Sherpa Mini direct drive extruder mounted on top. This does add a bit of weight on the tool head, but it also means that, well, it's a direct drive, so it's easier to tune and configure. And in my experience, you just get slightly better print quality over a Bowden. Next up, we have two 4010 part cooling fans on either side, or one on either side. And they're just blowing directly like in front of the nozzle. That's just to provide some part cooling. I didn't do any like flow modeling on them, but I just kind of pointed them at an angle where they would go more or less where the tip of the nozzle is. I haven't done any like real world testing on them yet either. I kind of need to do that. At the front here, we have, I think it's a 20 millimeter fan. That is blowing across the heatsink for the V6. I need to make some more cutouts in the back for the air to come through and some on the side. So right now it's fairly constrained and I'm not sure how well it's going to work. But I do have some air channels coming in through the side. I should actually grab some tweezers so I can point. One sec. So, I'm not sure if it's focused or not, I can't see the screen. Right here, I have a little air channel, there's one there, and there are a couple pass-throughs on the back, so that some air can go through this back plate and exhaust out the back. Otherwise, a lot of it's definitely going to be coming out the bottom down here. That's not great because in general, you don't want airflow, well, unintended airflow going over the printed area, but we'll see how it goes. I would like to be able to print at least PEI with this machine. If that extra airflow is a problem, you can just model up a water-cooled tool head using a one of those cheap just water-cooled heat sinks that are on Amazon. They look kind of like the E3D's Chimera Aqua, but they just have a single like tool head or spot for a hot end rather than the Chimeras too. Another thing a lot of you've probably noticed so far is that I have all these LEDs on this. That is just to provide a whole lot of light for a nozzle camera I'm gonna have. The nozzle camera is very much not necessary, but I think they are cool and I wanted one, and so I'm putting one on. Let's see what else. I have each tool head. It can have up to 2 little switches right here. These are just little clicky switches. They're the same ones that I used on the E3D's tool changer for probing the bed, and I'm using them for this same purpose on my printer. I'm using them to probe the bed, but I also have them here to detect whether or not the tool is actually grabbed onto the grabbing plate. And on that, this is an old version of the grabbing plate. It doesn't have any magnets in, so I can't really show you how it holds. But on this, there are these little pads right here. There's one on either side. And what those are for, those are what actually are pushing in the tip of the probe. So when this is mounted properly, the probes are on those pads, and you can, I'm not sure if you can hear it, but they do click. So they are registering. I'm not really sure on how to use these in firmware. I was probably just gonna wire one or both of them in series with a filament sensor, or just use them as a filament sensor, because I've never really used a filament sensor and I don't necessarily see the purpose. But the filament sensors, when they so the way filament sensor works is that just the simplest on or off filament sensor, it's either there or it's not, just binary filament sensor. When the filament is in, it's pushing in the switch. So then when there's no filament, the switch is extended, or in this case the switch is closed circuit when the filament is not there, and it's open circuit when it is, I believe. I don't know, I might be confused. This is one of the ways. But basically, this kind of works similar to the way you're detecting filament, because when everything is okay, when everything's working properly, the switch is pushed in, and it's registering that there's something there. And if this tool had to fall off, for example, these switches would then extend and they would go to their fault state, which will be detected by the main board, and it can pause the print and wait for human intervention. So you can see here, I'm just using some M4, I think they're like panhead screws is what they're called. They're the ones that are kind of have a dome shaped on them. And those locate onto, I don't have them installed on the grabber plate, but they locate onto some, I think they're 3mm steel rods that are located at 60 degrees around the magnet. Yeah, and down here is where the Z probe or Z switch mounts for mesh bed leveling. These little threaded inserts are for some 30mm brass standoffs, just to get the spacing correct from the back plate to this front grabber. Actually, I have the back plate right here. So this is the back plate. This little protrusion right here is where a USB endoscope camera kind of sits. If you kind of imagine, here, I'm going to get rid of this. If you imagine this mounted on the 3D printer, so this will be kind of the front right here. So this will be the front, and there will be the MGN9, I think I have 9H, the longer one, linear rail like mounting block right here. And then this will be on the back side, and that's just a little 3D printed part that will allow these to screw in on either side of it, and then they have screw holes to actually bolt it onto the linear block. Man, these work pretty well. This version doesn't have belt clamps for the inside. That was added on a later revision. Let's see if I actually have it. Yeah, right here. This is one with some pretty bad print quality, but it gets the point across. Right in here, there's some cutouts where I can slide in a belt, and then these little things sit inside here. And then from the front, I just have some 3mm holes that are chamfered. I just put an M3 screw in there. And with this, I can kind of just put this on the x-axis. Then this will be the little clamping spot is kind of pulled out a little bit when the screws are loose, and then I can just kind of tuck the 6mm belt into that gap, and then I just tighten the front with the Phillips screwdriver, and then it clamps it down really nice and tight. This printer isn't moving yet, so I don't know if this is enough like engagement with the teeth of the belt. I am hoping it is, otherwise I'm gonna have to figure out a new solution, but it should be fine because the belts aren't tensioned too crazy tight. I'm trying to think of other things. On the back plate, the belt holding system is pretty much the same, except it's going from the other side. So I don't have space constraints on this back piece. So I just have some holes right here for threaded inserts. Then there's a block that'll attach to the outside to clamp the belts on. I don't have an example of that nearby. But just imagine, instead of it being on the inside of it like this, it mounts on the outside surface. And then the threaded inserts will be inside of these holes, and the belt goes right in there. These brass inserts, they were threaded inserts, but I actually drilled them out just to have a brass surface for the M3 screws to engage, just for the M3 screws to pass through, for that attached to the 30mm standoffs between the front magnet holder plate and the rear plate. Keep throwing my tweezers. I don't know what's wrong with me. Trying to think of anything else. Can't really think of any. Yeah, I'm really excited for this tool head though, and it should work pretty good. I'm not sure if I said it, but eventually I won't have a steel disc right here. It will be another samarium cobalt magnet. It feels like it's attached well enough with just this disc, but the magnet will just provide even more like clamping force to hold this on to hold these two pieces together. Oh, one more thing. It's not on this revision, but on future revisions I have some little, I guess not really pegs, but just extrusions kind of that come off the side, like right here, and go up a little bit. And there's another one that goes like about here, and that goes up a little bit. And what that does is, if you look on this, it will be from here, kind of pulled up to here, and that just gives the tool head a little bit more support. Because what I was finding when I was doing testing with this is that when it was moving left and right really quick, with any reasonable acceleration, just for me, like throwing it around with my hands, I'll move this forward, and the tool had too much inertia, and it'll just fall off. But with those little extra support bits, here and right here, it was holding tight enough where it wasn't a problem. Yeah, I'm very excited for this. I'll post more videos with progress as they come. Yeah, hopefully this printer will be working within a few weeks. It's been a couple months in the making. I'm getting kind of antsy, just want it to work. Anyways, thank you for watching. Just like, comment, subscribe. The two of you who might actually see this. Anyways, Alex out. Bye.